Students, today we are going to start a new unit 4. In unit 4 we have total 3 chapters. In that first chapter is properties of triangles. Okay, first chapter today's class we are going to learn the properties of triangles. In this we have only some properties only, formulas, no problems, only formulas. Okay, properties of triangles. Before going to properties, we will learn some concepts. Circumcircle. What is the circumcircle? Circumcircle, the circle which passes through the all three vertices of a triangle is called a circumcircle. Means the circle that passes through the all the three vertices of a triangle is called a circumcircle. The center is called circumcenter. It is denoted by O, and radius is called circumradius. It is denoted by capital R. Means the circle which passes through the all the three vertices. All three vertices gunda pass a circle is called a circumcircle, and its center is called circumcenter, denoted by capital O, and radius is called circumradius and denoted by capital R. Okay, how it will looks like? This is a circumcircle. Suppose this is a triangle A, B, C. The circle which is passing through all the three vertices of a triangle A, B, C are vertices. The circle which is passing through all the three vertices of a triangle is called a circumcircle. It is a circumcircle, and this midpoint is called circumcenter. It is O, denoted by O, and this is radius. This distance, this distance, this distance, or any distance. This distance is circumradius. Circle yokka radius. That radius is called circumradius, capital R. Okay, the circle which passes through all the three vertices of a triangle is called a circumcircle. Next, and circumcenter is denoted by capital O, and circumradius is denoted by capital R. Okay, next, encircle. Encircle means the circle drawn inside a triangle. Means the circle is inside the triangle, which touching all the three sides of a all three sides of a triangle. Touches all the three sides is called a encircle. The circle drawn inside a triangle and touching all the three sides of a triangle is called a encircle. Its radius is called inradius, and it is denoted by small r. And center of the circle is called incenter. It is denoted by capital I. Incenter is capital I, radius is small r. How it will looks like? It is a triangle ABC. Triangle ABC. The circle which is drawn inside the triangle lopala, and it is touching all the three sides of a triangle. Triangles యొక్క three sides ni touch. Then this center is called incenter. It is denoted by capital I, and its radius, whatever may be the distance, its radius is in radius. It is called denoted by small r. Center is incenter, and radius is in radius, that is small capital I and small r. Okay. In radius smaller, in center is a capital I. Next, X circle. The circle which touches one side of a triangle, and other two sides produced is called X circle. Okay. Means how it will mean, because if it is a triangle ABC, if you extend this side and this side, it has one side, and extend these two sides. Extended sides in touch cheyali, and one side of triangle ni touch cheyali. The circle is called X circle. This is one X circle. If you extend this side, and this circle is second circle touching this side, extended sides. Next, if you extend this side and this side, you get this is the third circle. Total we get 3 x circles. Okay, one side and another 2 extended sides. Like you get 3 circles. These 3 circles are called x circles and its centers are I1, I2, I3. 3 circles, 3 centers I1, I2, I3 and radius R1, small r1, radius small r2, radius small r3. R1, R2, R3 are radiuses. Okay. Radius is called x radius, R1, R2, R3 and center is called x centers. 3 x circles are there. Centers are I1, I2, I3 and x circles radiuses are called x radius, R1, R2, R3. Small r1, R2, small r2, R3. So circumcircle which is passing through vertices of a triangle. In circle inside the triangle touching the all the 3 sides and x circle one side and extended 2 sides touching the outside of the triangle. 3 x circles are there. Okay. Circumcircle radius circumcenter is O and radius is capital R and in circle center is I and in radius is small r. And x circles centers are I1, I2, I3, capital I1, capital I2, capital I3 and radiuses are R1, R2, R3, small r1, small r2, small r3. Okay, next we will see the properties. Okay, properties we have some rules and notation here. The area of a triangle is denoted by delta. It is denoted by delta. Okay, it is delta. Denoted by delta and S equal to A plus B plus C by 2. It is called semi-perimeter. A plus B plus C. Small a, if suppose capital A, capital B, capital C are triangle. Opposite length of side is small a, opposite to B is length of side B and length of side small c. Then A plus B plus C is the perimeter. We are dividing by 2 means it is a semi-perimeter of a triangle. It is denoted by S. S equal to A plus B plus C by 2. Okay. Next. Properties. Relations between the sides and angles of a triangle. The relation. Then the first rule, sine rule. What it will say is sine rule. In triangle, any triangle ABC, small a by sin A equal to small b by sin B equal to small c by sin C equal to 2r. Small a by sin A equal to small b by sin B equal to small c by sin C equal to 2r, where capital R is circumradius. Circumradius means we learned the definition, circumcircle radius. It is called sine rule. A by this ratio, A by sin A ratio equal to B by sin B ratio is equal to C by sin C ratio equal to 2R. 3 ratios are equal to 2R. This is called sine rule. Next, from this sine rule, if you take these two, some note, A by sin A equal to 2R. A by sin A equal to 2R means small a equal to what? 2R into sin A, cross multiplication. If you take these two, B by sin B equal to 2R, then small b equal to 2R sin B. C by sin C equal to 2R means C equal to 2R sin C. This we will use in the problems. Small a equal to A by 2R sin A, small b equal to 2R sin B, C equal to 2R sin C. Here this capital A, capital B, capital C are angles. Okay, angles, and small a, small b, small c are lengths of sides of a triangle. Lengths of sides of a triangle. This is sine rule. A by sin A equal to B by sin B equal to C by sin C equal to 2R, where R is a circumradius. From this relation, we have small a equal to 2R sin A, small b equal to 2R sin B, small c equal to 2R sin C. Okay, next, second one, cosine rule. First one, sine rule is completed. Next, cosine rule. The cosine rule. In any triangle ABC, small a square equal to b square plus c square minus 2bc cos a. Small a comma b comma c are lengths of sides. If triangle ABC, any triangle ABC తీసుకుంటే స్మాల్ ఏ బీసీ సైడ్ యొక్క లెంత్ స్మాల్ ఏ, సిఏ యొక్క సైడ్ లెంత్ స్మాల్ బి, ఏబి యొక్క సైడ్ లెంత్ స్మాల్ సి తీసుకుంటే ఏ స్క్వేర్ ప్లస్ ఈక్వల్ టు బి స్క్వేర్ ప్లస్ సి స్క్వేర్ మైనస్ 2bc cos a. This capital A is the angle, this angle. Okay, a square equal to b square plus c square minus 2bc cos a, this is a one relation, and b square equal to c square plus a square minus 2ca cos b, it is another relation, and c square equal to a square plus b square minus 2ab cos c, this is the another relation. These three relations are called cosine rule. A square equal to b square equal to c square equal to. Next, note, from the relation a square equal to b square plus c square minus 2bc cos a, then if this 2bc cos a goes to right hand side, it is minus, if it will comes to plus, and this a square goes to this side, a square is plus, it will goes to minus, means b square plus c square minus a square 2bc cos a. Therefore 2bc cos a equal to b square plus c square minus a square. This 2bc, LHS side it is multiplying, if it will comes to RHS it will divide. So cos a equal to b square plus c square minus a square by 2bc. Cos a equal to, from the first relation, a square equal to b square plus c square minus 2bc cos a equal to that. From that relation, cos a equal to b square plus c square minus a square by 2bc. Similarly, second relation, we have cos b equal to c square plus a square minus b square by 2ca. C square plus a square minus b square by 2 square. Cos c equal to, similarly, third relation, a square plus b square minus c square by 2ab. You have to remember these formulas. If sides are given, to find the angles A, B, C, we use these formulas. Okay, cos A formula, cos B formula, cos C formula. A is there, we have to start with b square, c square minus a square by 2bc relations. Okay, this is the cosine rule. Cosine rule means these three statements: a square equal to b square plus c square minus 2bc cos a, b square equal to c square plus a square minus 2ca cos b, c square equal to a square plus b square minus 2ab cos. Okay, from this we written cos a, cos b, cos. Next, projection rule. Third one is projection rule. In any triangle ABC, small a equal to b into cos c plus c into cos b. Here these b comma c are lengths of sides. This capital C and capital B are angles. Okay, how to remember this one means A. If you it is a circle, ABC, three are there. A equal to b into cos c, another cos c. Then these two are interchanging. Angle and sides are interchanging. C into cos c. A tarvata vachedi enti after b. ABC, if you take ABC is a in cycle A, B, C. Link A equal to b cos c, and these two will be interchanging. C into cos b. Then b equal to c into cos a, interchanging a and c, a into cos. Next, c equal to a into cos b plus b into cos. These relations are called projection rules. Okay, a equal to b cos c plus c cos b, b equal to c cos a plus a cos c, c equal to a cos b plus b cos c. Okay, next, the law of tangents. The law of tangents says that in any triangle ABC, a minus b by a plus b equal to tan of capital A minus b by 2 by tan of a plus b by 2. Here capital tan means angles, a comma b are angles, here a comma b are lengths of sides. Okay, first law of tangents. First one, a minus b by a plus b, that ratio is equal to tan of capital A minus b by 2 by tan of a plus b by 2. Next, second one, b minus c by b plus c equal to tan of b minus c by 2 by tan of b plus c by 2. Next, c minus a by c plus a equal to tan of c minus a by 2 by tan of c plus a by 2. These are called the law of tangents. Okay, you have to remember these rules. First one sine rule, next one cosine rule, next projection rule, next law of tangents. Projection rule and law of tangent. These four questions, four rules and law of tangents will come in short problems. Write the sine rule. Direct question, write the sine rule or write the cosine rule or write the projection rule or write the law of tangents. Direct question will come in short questions. Okay. Next, I will do problems. Actually, problems are not there, but I am taking some problems. Okay. First one, in any triangle ABC, prove that sin A plus sin B plus sin C equal to S by R. Sin A plus sin B plus sin C equal to, we have to prove S by R. So I am taking LHS sin A plus sin B plus sin C. What is the sin A? From the sine rule, we have A equal to 2R sin A. Therefore, sin A equal to this 2R comes to this side, divides A by 2R. Sin A equal to A by 2R. Similarly, sin B equal to B by 2R. Sin C equal to C by 2R. From the sine rule, we have A equal to 2R sin A. From this, 2R comes to RHS, it will LHS, it will divide A by 2R. Sin A equal to 2R, A by 2R. Like that, sin B equal to B by 2R, sin C equal to C by 2R. So I am substituting the values A by 2R, B by 2R plus C by 2R. 2R is the LCM, numerator will comes A plus B plus C. And we have A plus B plus C by 2 equal to S. Therefore, A plus B plus C equal to 2 goes to this side, 2S. Therefore, A plus B plus C equal to 2S, 2R as it is. 2 cancel S by R. That is the RHS. Okay. Sin A plus sin B plus sin C equal to S by R. Next. If small b equal to root 2, small c equal to root 3 and capital B equal to 45, then find the angle C. Okay, given what? Small b is given, small c is given, capital B, angle is given, we have to find angle C control. So given values B, C, capital B, and we have to find angles. And by sine rule, we have what is the sine rule? A by sin A equal to B by sin B equal to C by sin C equal to 2R. So I am taking these three ratios are equal to 2R. I am taking these two because we related with small b, small c, capital B, capital C. I am taking this relation B by sin B equal to C by sin C. I am taking only these two. These four are equal. I am taking these two only. B by sin B equal to C by sin C because I am related to this small b, capital B, capital C. Therefore, I am taking this one. Cross multiplication B into sin C equal to C into cos B. So sin C equal to this B goes to RHS, C by B into cos B. So substitute the values. In this C value, substitute the C value and B value and cos capital B value, cos 45. That is next slide. So sin C equal to C by B cos B. C means root 3, B means root 3 and root 2 and capital B equal to 45, cos 45 means root 3 by 2 into cos 45. What is the cos 45 value? Root 3 by 2. Cos 45 value is 1 by root 2 and root 2 into root 2, that is root 3 by 2. That is sin C equal to root 3 by 2. Root 3 by 2 means sin 60 degrees. Sin C equal to sin 60 degrees means C equal to what? 60 degrees. Capital C equal to 60 degrees. This is the answer. Okay. Here given small b is given, C is given, capital B is given. We have to find capital C. So from this, I am taking from the sine rule B by sin B equal to C by sin C, C by sin C, this relation, and substituting three values. Small b, small c and capital B, I am getting capital C. Next, Next problem, you have to do the homework problem. Similarly, small a equal to 1, small b equal to root 2, capital B equal to 90 degrees and capital A equal to what? Angle capital A. If you find out, we get capital A equal to 30 degrees. How means? It is same similarly from the sine rule, A by sine A equal to B by sine B equal to C by sine C equal to 2R. In the question we are related with these two only. So we have to take A by sine A equal to B by sine B. That's all. Small A by sine A by sine A equal to B by sine B. Equate these two and substitute the values. Small a value, small b value and capital B value, we get sine A. Okay, sine A also, from that we get capital A value is 30 degrees. Okay. So today's class we discussed about the first of all properties of triangles. In that we discussed about circumcircle definition, incircle definition and excircle definition and relations, sine rule, cosine rule, projection rule, the law of tangents. These rules are very important. This will come direct. Okay, these problems are, I am only telling that, but in this chapter no problems, only rules that will come directly as a state sine rule, right sine rule, right projection rule, right cosine rule, right the law of tangents. These problems will come in the 6th unit. Okay. Complete the fair notebook and do the homework problems. If you have any doubts, feel free to ask me and send a message or call to me. Okay. Thank you.